Why are topographic maps essential for understanding drainage basins? Imagine trying to understand how water moves across a landscape without a clear picture of the land itself. It would be like trying to navigate a maze blindfolded. That's where topographic maps come in. They are like detailed blueprints of the land's surface, showing elevation, slopes, ridges, and valleys. These features are key because they shape how water flows and where it collects. A drainage basin is an area of land where all rainwater and runoff drain toward a common outlet, like a river or lake. To understand where one basin ends and another begins, you need to see the high points and ridges that separate them. Topographic maps display these ridges with contour lines, which are lines connecting points of equal elevation. By following these lines, you can trace the boundaries called drainage divides. These divides act like natural walls, directing water into different basins. Knowing the exact shape and size of a drainage basin helps in many ways. For example, it helps scientists predict how much water might flow during a storm. It also shows which areas are likely to flood or erode. When you look at a topographic map, you can see the network of streams and tributaries inside a basin. This network is called drainage density, and it tells us how quickly water moves through the landscape. Steep slopes and impermeable surfaces usually mean a high drainage density, which can lead to faster runoff and more erosion. Flat or permeable areas tend to have lower drainage density, meaning water moves more slowly and spreads out. These maps are also useful for managing water resources. They help identify where to build dams, plan flood defenses, or conserve ecosystems. Land developers can see which areas might be prone to flooding or erosion before starting construction. Engineers and hydrologists use topographic maps to model water flow and predict how changes to the land might affect the entire water system. In short, topographic maps are essential because they reveal the physical features that control water movement. They show the terrain that shapes drainage basin boundaries, flow paths, and stream networks. Without these maps, understanding how water travels across the land would be much more difficult. They are the foundation for studying and managing water systems, ecosystems, and climate impacts on the landscape.